Welcome to our presentation, Elementary Science 101 for the intermediate classroom. During this presentation, you will learn more about the elementary science classroom, why teaching science is important, what students are learning, how they are learning, what you would see in a science classroom, what students experience, how science is taught at the elementary level, resources used to help instruct students, and how you as a caregiver can support science at home. Everything we do in our district aligns to our district vision and mission, which is to prepare students for life, which is our vision, and provide an education and the supports which enable each student to excel as a successful and responsible citizen, which is our mission. For this activity, you will just need a piece of paper. How can you physically change the piece of paper? Take a few minutes to physically change the paper. When you are done, please draw a picture of how you change the paper physically in your notebook. Don't forget to label your drawing. This is a quick and easy activity that connects to a science standard for 5th grade. This standard includes changes to matter that are physical and chemical. We only focused on the physical part of changing the paper. But could we chemically have changed this paper? This type of activity can also connect to other standards in different grade levels as well. So this could be an example of a hands-on activity that you can do at home with your child. We will be sharing other quick and easy hands-on activities that you can do at home later in this training. Please read the quote on the screen. This quote serves as a compelling reason why we teach science in the elementary classroom. Science is a part of our daily lives, and as we head into the future, it will be more vital in all aspects of what we do. For that reason, we must develop scientific literacy in our students so that they are prepared for the world in which they live. For this slide, you will need your grade 3 through 5 NGSSS foldable, which is in your packet, markers, crayons, or colored pencils. The learning that takes place in the science classroom is aligned to the next generation Sunshine State standards that were adopted in 2008 by the Florida legislature. Each grade level has their own specific standards that each student should master by the end of each grade level year. The standards fall into 4 bodies of knowledge: nature of science, or NOS, physical science, earth science, and life science. Each body of knowledge is further broken down into big ideas which have standards connected to them. Even though each grade level has their own specific standards, each year builds upon and/or is connected to the previous year's learning. We are going to provide you with a few minutes to look over your child's specific grade level standards so that you can become a bit more familiar what they will be learning with this year. Now that you've been able to look over the next generation Sunshine State standards for your child's grade level, please take out your science notebook. On the next page in your notebook, please draw a sun at the top of the next page. This is to represent the NGSSS, and write one thing that you were surprised to see your child will be learning about this year. For this slide, you will need your science notebook. In the science classroom, discussion is a key component to learning science. To show you an example of how discussion can be a strategy that is often used in the science classroom, we are going to model a strategy called PB and J. This strategy is a way to get students to turn and talk to their neighbors about their thoughts and ideas in science. The P stands for the pivot, the action of turning to your neighbor. The B stands for blab, referring to talking to their neighbor. And the J stands for jot, which refers to writing what you have discussed and heard in your science notebook. At this time, I would like for everyone to PB and J about what you wrote in your notebook regarding the next generation Sunshine State standards and what surprised you. We're going to take about 2 or 3 minutes to do that. As you can see, Conversation in science is critical for students to share their learning, questions they have, and time to make sense of the science concepts they are learning. Conversation also fosters collaboration, and this emulates how real scientists go about their work. This structure is just one example of how teachers engage students in scientific talk. For this slide, you will need your science notebook. Teachers in Hillsborough County follow a specific model to instruct students in science. This model is called the 5 E's of Science Inquiry Model. The 5 E's are engage, explore, explain, elaborate, and evaluate. The engage portion of a lesson is where the teacher provides the students with a quick model of a hands-on investigation, a demonstration of a scientific phenomenon, an engaging video, a scientific scenario. Something that is going to get the students interested in the science that they will be learning about and curious, where they begin to ask questions. We did a mini engage at the beginning of this presentation with physically changing the paper with our hands-on activity. The explore portion of the instructional model is where students are involved in a hands-on investigation or experiment to begin interacting with the scientific concept or topic that they will be learning about. Here they are using materials to explore a concept that is new to them or adding new learning to something they've explored before. The explain part of the inquiry model involves students making sense of science. They are making connections between the hands-on investigation and vocabulary, engaging with complex text that supports the science, viewing scientific-based videos, recording their thoughts and new learnings. This will help them connect to the science they are learning. If there is time to elaborate on the science, students are going deeper within the topic they are learning and being presented with different hands-on experiences. Alternative pieces of text are among other things to extend their learning. Throughout the entire 5 E's process, the students are being evaluated by their teacher through daily observations, exit ticket questions to monitor learning, understanding, or possible misconceptions. They also look at scenario-based probes, assessment, and quizzes. As one can see, the science classroom is very busy with many different strategies going on at one time to make sure students learn the specific standards that are being addressed. At this time, please turn to the next page in your science notebook and draw the graphic to represent the 5 E's of the inquiry model. This is to help you remember the model and its components. For this slide, you will need a half-sheet week-at-a-glance chart that is in your packet. When looking at a week in science, globally we can look at it in terms of 2 parts, Mondays and Tuesdays through Fridays. Inquiry Mondays are reserved for focus of the nature of science standards in terms of the scientific process skills. STEM Fair, formerly known as the Science Fair, and STEM Design Challenges. So on Inquiry Mondays, students are engaged in lessons that focus on developing these skills apart from the content standards. The majority of the first 9 weeks, the Inquiry Mondays are dedicated to the process skills and learning about and completing a STEM Fair project. After that, students are involved in a STEM Design Challenge that spans 4 weeks at a time. These STEM Design Challenges were created to provide students with the opportunity to experience how engineers create and design solutions to solve real-world problems. Tuesdays through Fridays are dedicated to the content standards that fall under the physical, earth, and life bodies of knowledge, and also connect the nature of science standards throughout instruction. The students are exploring the content standards through the 5 E's instructional model that we discussed on the previous slide. The typical week's activities in science varies from week to week and from classroom to classroom. However, the basic components and time devoted to hands-on, student talk, students work independently, and teacher talk should follow this model. Approximately 60% of students' time in a week in science should be spent to hands-on instruction, where students are actively engaged with the science using tools and manipulatives. Discussion in science by students with peers should be approximately 20 to 25% of the weekly time in science. Approximately 10 to 15% should be spent on independent practice, as well as 10 to 15% on teacher talk. It is important to reiterate that these percentages reflect time spent in a week, not in a day. If you were to walk in a science classroom, you would see lots going on. As we discussed earlier, the science classroom is very busy and students are actively involved at all times. Here are some of the things you might observe when entering a science classroom. Vocabulary word walls. You would see science words on the walls that students are currently learning or have learned recently. The science classroom places a huge emphasis on science vocabulary because it is a critical component of science understanding and comprehension. You will see students expected to use the science vocabulary in their discussions with the teacher and peers, as well as in their writing and assessments. Thus, the use of a word wall in science is important to help students with those expectations. Science tools. Science tools such as hand lenses, droppers, balances, etc. can be seen in a science classroom as tools for students to use when exploring new concepts and ideas in science. Science-based anchor charts. The students are constantly learning new things and making connections, so oftentimes teachers will use anchor charts to help students remember their learning and to have something to reference when making connections. Students work on walls. Classrooms will also have evidence of student learning and highlights of student work up on the walls for everyone to see. Small groups. The science classroom is very interactive, where students work in small groups to accomplish tasks, answer questions, explore, and discuss the science topics presented to them. We will also see long-term investigations. Students are constantly learning how real scientists go about their work and how science often happens over a long period of time outside of the 60 minutes of instruction spent every day. So students explore science through long-term investigations, where they are able to observe science over time and collect data. Long-term investigations can be connected to what students are learning in their core instruction, but can also be based on topics that students are interested in exploring outside of core instruction. The essential questions. Instruction in science is connected to an essential question, in which students should be able to answer by the end of the course of study, which could be at the end of that day's lesson, at the end of the unit, etc. These questions guide the lessons that are the focus for students to help teachers monitor the students' learning. Classroom discussions. The science classroom is not a quiet one. It is filled with rich discussions, questions, and scientific argument. Students often learn from their peers and are so encouraged to discuss questions posed by their teachers with their peers in the classroom. Student discussion is not only good for students, but great for teachers in terms of evaluation and monitoring student learning and possible misconceptions. Student notebooks. A critical component of the science classroom are science notebooks. Students use science notebooks to record their observations, draw and label to show their understanding and learning, answer rigorous questions posed by their teachers, summarize their thoughts and learning, and gather data from investigations/experiments. Science notebooks are used daily and catalog the learning by students as they progress through the year. Engaging with science text. Students can also be found reading and engaging in science text in the classroom. Use of informational text in science is one way in which students connect their hands-on exploring to the science behind it. For this slide, you will need the mygconnect.com login information that is in your packet. In the science classroom, there is a core resource text, National Geographic, that students have access to both physically in the classroom and online. The National Geographic textbook is a resource that teachers use to help students connect their learning from their hands-on to vocabulary, science concepts, real-world images, and examples of science they are currently learning about. The text is also available online through the website mygconnect.com. On the website, students and families have access to the student textbook, an image library, vocabulary games, and much more. Please refer to your packet for the login information on mygconnect.com. There are different ways that students are assessed in science. Students have multiple opportunities to show what they know and can subsequently get enrichment or remediation based on how they perform on the assessments in science. The slide lists many of the assessments that may use to measure students' performance in science. As you can see, there are many opportunities for students to show what they know. Teachers use multiple assessments to evaluate student knowledge. For this slide, you will need the materials Tips for Busy Caregivers, the NSTA article. We learned earlier in this training that science is everywhere, so school isn't the only place that learning of science concepts takes place. A child's home is a wonderful place to learn and experience the world around them. There are many ways in which caregivers can support this learning of science at home. Please turn in your packet to the NSTA article, Tips for Busy Caregivers. The article lists different ways in which caregivers can support science at home. We will discuss a few of these tips from this article. See, science is everywhere. What would happen if is a great thing a caregiver could ask their child. Questions or present brain teasers to encourage children to be inquisitive and seek out answers. Children need to know that science isn't just a subject, but it's a way of understanding the world around us. Lead a family discussion on science-related topics. Dinner time might be an ideal time for your family to have discussions about news stories that are science-based, like the International Space Station missions, severe weather conditions, or new medical breakthroughs. Over time, children will develop a better understanding of science and how it affects the many facets of our lives. Movies and TV shows with science-related storylines are also great topics for discussion. We want to encourage both boys and girls equally by doing science together. Children, and especially elementary age students, learn better by investigating and experimenting. Simple investigations done together in the home can bolster what your child is learning in the classroom. Check with your child's teacher on what your child is currently learning in the class and what activities you can explore at home. There are many books on the market and numerous websites that present ideas for investigation. Connect science with a family vacation. Family vacations are a great way to explore science. It could be a hiking trip to where you explore nature or a discussion on tides during a beach vacation. Become active in your child's formal education by getting to know the teacher and the curriculum. Attending this caregiver's presentation is one step in getting to know your child's education. We have just highlighted a few of the ways in which caregivers can support science at home from the NSTA article. Please feel free to read the article in more depth on your own for more information on the way you can further support science at home. For this slide, you will need the materials MyOn Login and book list in your packet. Science and reading are closely connected in terms of supporting science comprehension and learning. To further support science at home, caregivers are promoting reading science-based literature at home. Encouraging your child to read books connected to science, whether fiction or nonfiction, can really help students learn and explore science. The National Science Teachers Association, NSTA, releases a list of trade books every year for caregivers and teachers that are science-based and engaging for children. In your packet, please reference the 2015 list from the NSTA. These books can be purchased, borrowed from a local library, or found on MyOn, a resource that is available online to all students in Hillsborough County. For this slide, you will need your notebook, a marker or crayon or colored pencil. We learned earlier that vocabulary in science is one critical component that helps students comprehend and understand science concepts. We encourage our students to use science vocabulary when talking about the science they are learning and when writing about science in their notebooks. In order to use a science word, one must truly understand its meaning. Practice and multiple exposures to the science words is key to true understanding of science vocabulary. One easy way for caregivers to support this is by practicing science vocabulary at home. Please open your science notebook to the next page and create the four-square vocabulary organizer on the screen with the animals listed in each square. Take a moment to discuss at your tables the one word that does not belong and describe why. Please take turns explaining your thoughts. There are multiple answers to this question because it depends on your perspective. If you are looking at the type of animal, then it may be the butterfly because it does not belong since it's not a bird. If you're looking at it from the perspective of animals that fly, then the penguin wouldn't belong. This is a model of how students practice with vocabulary in science. Students do not just learn the meaning of a word one time. They often interact with a new word in science in many different ways, including vocabulary games and activities like this one. This type of activity can be easily done at home. You can create a four-square with words you know your child is learning. Caregivers can ask for a list of words from teachers and ask their children about what words they are learning about in science. They can do the same activity during dinner, after dinner, in the car, etc. For this slide, you will need the materials tracking the rain data chart and graph sheet and the questions handout from the packet. Another way to support science at home is through data collection. Students are involved in data collection through long-term investigations at school on a regular basis. So doing this practice at home as well can support overall understanding. Here is an idea for a long-term investigation that can be done at home. One idea is to track rain patterns over a span of time. All you need is a data chart, a graph, and time to collect the data daily. In your packet is an example of a data chart and graph that you could use to collect the data on rainy days and non-rainy days. To collect the data, all you would have to do with your child is to look at the weather for the day to see if it has rained or not. If it has rained, you can put an X in the column under rain. If it didn't rain, then you would put X in the column under no rain. At the end of a specific amount of time, a month or two, you could count how many days it rained and how many days it didn't. Once you have the data, you can show it on a graph. After showing the data in both the chart and the graph, ask the child specific questions to help them formulate a conclusion. Please refer to the question sheet in the packet for examples of questions you can ask your child when we look at the data. Are there any questions? Once again, thank you for spending time with us today. For additional help, ideas, and information, please contact your student's teacher. For information regarding Hillsborough County Public Schools elementary science events and policies, please contact Shauna Tirado, Elementary Science Supervisor. You can email her at shauna.tirado@sdhc.k12.fl.us. Thank you for your continued support of science.